Hi guys, welcome to your first video of this week. Some good news for you if you're watching this. This week we only have 2 videos of new information instead of 3. So yay, less work for you guys this week. So actually our entire lesson this week is just section 8.5, which is on adding and subtracting rational expressions. So we're going to go through some of the more basic, a little more simpler ones today, and then we will move into the more difficult ones in our next video. So only the 2 videos this week, okay? So you'll have only 3 quizzes assignments this week instead of 4. So 1 from each video and then 1 for the final one for this week. The bigger one over all of this week actually includes last week as well. So it's also going to include simplifying, multiplying, and dividing, and then adding and subtracting. So it's going to cover all of that. So make sure you have that flow chart handy that kind of shows you your step-by-step on how to attack your problems. All right, but for today, we are adding and subtracting with like denominators and also unlike denominators. So we need to kind of think back to, regular old fractions. How do you add and subtract normal fractions? So going back into, let's see, my son's working on this now in 4th grade. He's working on fractions. So this is a 4th grade skill. So 2/7 plus 3/7 would be 5/7. So the denominator needs to be the same. It stays the same. And then you go ahead and add the numerators. Okay, number 2 here, 11/15 minus 1/15. They're both 15ths, so it stays a 15. And 11 minus 1 is 10. But then both of these can be divided by 5. So that becomes 2/3. So you want common denominators first, and then you can add or subtract the numerators. Denominator stays the same, and then you want to simplify after that. So kind of keeping those thoughts in mind as we go through here. Number 3, 3/4 plus 5/14. They are not like terms right now. So we need a common denominator. So what number can you turn both 4 and 14 into? And I can turn them both into a 28. So common denominators are never smaller than what you start with. Okay, so looking at them, you can never make them smaller. So I have to have something that I can multiply both of them and turn them into. So I can multiply 4 times 7 to get 28. So if you multiply the bottom by 7 to make it 28, multiply the top by 7, gives me 21. 14 times 2 made 28, so 5 times 2 is 10. Because I'm not changing the value, I'm just rewriting them in such a way that the denominators are the same. So then I can keep the common denominator, and then 21 plus 10 would be 31, and nothing divides into both. You can leave them top heavy, and then we would be done. Okay? So kind of thinking about regular old fractions, you need to get a common denominator. The denominator then stays the same, and then you just add the numerators together. Okay? So looking at number 3, I got my common denominator of 28. I had to be at least as big as the 4 and 14, but in this case I made them bigger. So I made my common denominator, and then it said multiply by the missing piece. This 4 was missing the 7 to make it 28, so then I multiplied the top by that 7 also. The 14 was missing the 2 to make it 28, so then I multiply the top by 2 as well. So that's kind of what I'm... So let's try some basic ones here. What if they already have like denominators? Let's get some practice there before we move into the harder part of getting the common. All right, so we have 7 over 4x plus 3 over 4x, which means you are going to keep the common denominator of 4x. 7 plus 3 is 10. And then can you simplify? Yes, I can divide both of them by 2. So you would get 5 over 2x. Now, also thinking back to restrictions, remember that from last week. X would not be allowed. Again, if you were looking here, it'd be 4x cannot be 0, so divide by 4, so x cannot be 0. That would be your restriction. All right, number 2. The big thing with subtracting, that's where some people get themselves in trouble. This minus that you see right here, that goes to this entire fraction. If you remember, we've talked before, if you had a negative here, let's say I had a negative 2 and then 3, you could rewrite that as negative 2 over 3, or you could write that as 2 over negative 3, but negative 2 over negative 3? No, because then two negatives make a positive. So you either use it on the top, right? This one I used it on the top, this one I used it on the bottom, but don't do both top and bottom because two negatives make a positive. Okay, so we want to use it typically, I'm going to tell you right now, I always put it on the top. Okay, so I'm going to distribute this negative. So that 5 I turn to a negative 5. If I had a negative in front of my fraction and I had like x plus 5 sitting here, I would distribute that negative to both parts to make that negative x minus 5. So this negative that you see in front of a fraction, it goes to everything on that top. Again, I'm not doing top and bottom, right? Like this fraction I scribbled off right here. That makes two negatives, which is positive, which is not what I wanted. All right, so I have a common denominator of x plus 6. And then on the top, I have a 2x minus 5. Those are not like terms, so there's not much I can do with it. Excuse me, sorry about that. All right, so moving forward from here, can you simplify? Can I cancel those x's? No, I can't cancel those x's. Remember the super glue we talked about last week? If it's held with a plus or a minus, it's glued together with that, and I can't take that away. All right, so that's as simplified as it can be. Restrictions, remember those come from your denominators. X plus 6 is not allowed to be 0, so x cannot equal negative 6. And there's my restriction. Slides, hang with multiply. All right, just a couple more kind of basic ones here. So number 3 already has a common denominator of x minus 7. And then on the top, I have 2x plus x, which is 3x. And then I have minus 21. Then looking here, can I do anything to simplify? Well, I can actually factor the top. I can take out a 3, which leaves x minus 7 over x minus 7. I should probably look at my restrictions. So x cannot equal 7, right? Coming from x minus 7 not being able to be 0. And then I can cancel x minus 7 on top and bottom. So I am left with just 3. All right, number 4, notice the minus sign in between the fraction. That minus sign is going to react just like we talked about on my last slide, right? It's going to get distributed. So if I distribute that, that's going to change that to a negative 3 and a positive 5. Okay, so I'm going to use that negative to put it on the top, right? I distributed the 3x became negative 3x, negative 5 became positive 5. It changes all your signs, right? Think back to long division, right? When you put the minus to subtract, it changed all your signs. Don't do top and bottom, right? Because that makes two negatives, which is positive, which means it's like you're not even subtracting it. Okay, so common denominator is x minus 1. And then on the top, I have a 5x minus 3x, which is 2x. I have 6 plus 5, which is a positive 11. Restrictions, x cannot equal 1, right, coming from the denominator. And can I cancel? And I have x on bottom being super glued, x on top is super glued with something, so there's nothing else I can do. Nothing factors, nothing I can cancel. That can make it the same. All right, so let's kind of move into some that are just a little bit harder, where you have to get the common denominator, okay? So now the denominators will not be the same right from the start, and let's kind of talk about how we do this. So we will factor the denominator. Now normally everything just said factor, right? And we just factored everything possible. This is where things change a little bit. So adding and subtracting have very different rules from multiplying and dividing. Multiplying and dividing, everything was kind of fair game. Any top, any bottom, we canceled, we moved things, whatever. So It is different here. When we are adding subtracting, our goal is to get common denominators first, put it together, then try to cancel things. Okay, so first thing we need to do is just factor the denominators because we're trying to make those the same. Then we're going to determine the LCD, the least common denominator. Now I have on here that you must use every piece. You can't just kind of leave things out. So everything you see and all of your denominators has to be accounted for. I can't ever make them smaller, remember? Has to be at least as big as the number there, if not bigger. So keep in mind what is super glued together with a plus or minus. And then in order to get common denominators, you multiply the top and bottom by its missing piece. So after you do that, you keep the common denominator, factor again if you can, and then cancel what you can. So we'll get more practice with this, but let's kind of talk about tips for finding the LCD, because that's usually where students struggle the most. So every factor must be represented. Every factor. So that needs to kind of keep in mind of that super glue. If it's super glued together, it has to stay together, and that counts as something different. Like if one denominator has an x plus 4 and one denominator has a 4, they're different, okay? So the common denominator here, right, just looking at the LCD, the common denominator, would have to be a 4 and an x plus 4 because these are separate. I can't turn a 4 into an x plus 4 because these are super glued together. I can't just add an x plus in front of it. That doesn't make any sense. So they are like two separate things. For factors that are repeated, use the largest amount that is repeated. So what that's referring to is if this one has like an x plus 2, and this one has x plus 2, x plus 2, the least common denominator between these would be x plus 2 and x plus 2. I would need to use two of them because this one already has 2, so it's not really missing any piece to turn it into that. This one would be missing another x plus 2, so I would multiply top and bottom by the piece that it was missing in order to make it look like the other one. This goes back to I can't make it smaller. It has to be at least as big as it is, if not bigger. Cannot make them smaller. For monomials, things that don't have super glue, holding them together, find the smallest number that both numbers go into. Again, back to example number 3 that we already looked at, right? The 7 and the 14, or the 4 and 14. Can't remember what those were. We turned it into 28. So that's what that's kind of referring to. And use the largest amount of the variable. So again, if I go back to that example, if I had a 4 and a 14, this has an x squared and this has a y. So the common denominator between these would be 28x squared and y. Because this one I could multiply by 7y to make it that. This one would get multiplied by 2x squared. So you have to be able to multiply it by something to make it the common denominator. So as you can probably already tell, this is where we get kind of tricky with things, which is why this week you only have the 2 videos and all we're focusing on is adding and subtracting this week. It gets tricky. You're going to have to take some time to work through it. All right, so here we go. Number 1, and I kind of broke it down into 7 steps. This is what's going to be on your flow chart. This is the easiest way I can kind of break it down for you. My biggest advice at this point is to read your steps, okay? But first and foremost, if you ever see a minus sign like I do right here, we want to not leave it in front like that, but either put it on the top or the bottom. I, again, recommend to always put it on the top. So distributing that through, changing the signs. So this is now gone, and it's up there as a -6, okay? All right, so first thing is to factor denominators. X minus 4 doesn't factor. X plus 3 does not factor. Find the common denominator. So I need to, again, this is a super glued piece. It has to stay in x minus 4. And this is a super glued piece, x plus 3. So that has to stay x plus 3. I have to keep both pieces. Okay, again, we cannot make them smaller. I have to use every piece you see. So I have an x minus 4 and an x plus 3. All right, so moving forward, in step 3, multiply each fraction by the missing piece to obtain a common denominator. So again, what does this fraction need? I'm looking at them, these are kind of like separate fractions now, right? What does this fraction need to look like this? Well, it's missing the x plus 3. If I put an x plus 3 on it, now it looks the same on the bottom. So that means I also multiply the top by x plus 3. Notice it doesn't say smoosh. It says multiply. Actually multiply. X times x is x squared. X times 3 is 3x. All right, doing the other fraction. What is this one missing to look like this? Well, it's missing the x minus 4. So that means I multiply the top by x minus 4. Multiply, don't just smoosh it together. So I get negative 6x plus 24. All right, step 4, add the numerators. So collect your like terms. I have an x squared. I have like terms here in the middle. 3x minus 6x is negative 3x plus 24 over x minus 4 and x plus 3. All right, once it's a common denominator, I kind of put it all together. Step 5 is my restrictions. So restrictions come from the denominator. X cannot equal. That first one gives me a 4. That one gives me negative 3. Factor the numerator. Notice in the beginning I only factored the denominator. It's already in factored form. Can I factor the numerator? Well, options for 24 is going to be 1 and 24. We're going to have 2 and 12, 3 and 8, 4 and 6. And I'm trying to get a negative 3x in the middle. None of those are going to work. This actually does not factor. So step 7, does anything cancel? No, it does not. And I am done. Now I know this is a bit much, so hang with me. We're going to do lots of problems, and we'll have some of the easier ones today. The next video that you'll watch for this week will have some of the harder ones. So just kind of hang with me, okay? Don't give up yet. Keep watching. All right, so number 2, step 1 is factor denominators. Neither one of these factor, so that step is done. Find the LCD. This is super glued together. That is super glued together. So for a common denominator, I'm going to need an x plus 2 and I need an x minus 2. You have to represent every piece that's in the bottoms. Okay, and I can't make them smaller. And they're super glued together, so I can't break them apart either. All right, so I did that step. Step 3, multiply each fraction by the missing piece. So again, these are almost like separate fractions here. What is this missing to look like this? It's missing, on the bottom, it's missing the x minus 2. So that means I also multiply the top by x minus 2. So how do you multiply that? We got to distribute. So x times x is x squared. X times 3 is 3x. 2 times x, negative 2x. And negative 2 times 3 is negative 6. All right. The other fraction, what is this missing to look like this? It's missing the x plus 2. So we will multiply the top by x plus 2. So we distribute, and we get 4x plus 8. All right, so that was step 3. Step 4, add your numerators. So in other words, put your like terms together. We have an x squared, and then I have 3x minus 2x is 1x, plus 4x is 5x. Negative 6 plus 8 is a positive 2 over that common denominator. Okay, that step's done. Restrictions, x cannot equal, we get plus and minus 2. Oh, that was terrible. Plus or minus 2. Done. Factor the numerator. That's not going to factor. So then does anything cancel? And the answer is no. So we are done. All right, number 3. So again, I see right away, I recognize there's a minus in front here. So we want to distribute that negative. All right, let's get rid of that here. We distributed it through. So step 1, factor denominators. That does not factor, but it's superglued. That does not factor, but that's superglued together. So can't do anything there. The LCD, my common denominator, I need the 2y plus 1. That's a superglued piece. And the y plus 1, that's a superglued piece. So I know they look really close, but I can't just stick a 2 in front of that y and make them the same. Right? They're superglued together. I have to keep those pieces as those pieces. All right, so found my LCD. Multiply each fraction. What is this? Again, these are different fractions. What is this denominator missing to look like this? It's missing the y plus 1. So that means we multiply the top by y plus 1. So multiply, actually distribute, we get 3y squared, and then plus 3y. What is this one missing to look like this? It's missing the 2y plus 1. So we will multiply the top by 2y plus 1. And again, that's going to need to be full distribution. Negative y times 2y is negative 2y squared. Negative y times 1 is negative y. Negative 3 times 2y is negative 6y. Negative 3 times 1 is negative 3. All right, that was step 3. Next, add numerator. So put my like terms. So let's see, I have a 3y squared minus 2y squared is y squared. 3y minus y is 2y. Minus 6y is negative 4y. And then I have a just minus 3. All right, on the bottom, we have 2y plus 1 and y plus 1. All right, next step after adding numerators is my restrictions. So y cannot equal. That one gives me negative half. That one gives me negative 1. All right, so that's my restrictions. Factor the numerator. So it looks at a quick glance that that'll factor, but actually it doesn't. Trying to factor, you might be like, yeah, it does. Y in 1, y in 3. And if I have them both negative, I get negative 1y minus 3y, it works. But since this one is negative, one of these signs would have to be positive, so it doesn't work. So nothing factors, which means nothing's going to cancel. So this is my final answer. When things cancel. Unfortunately, we haven't had that where they canceled like crazy yet, but it's coming. All right, number 4. Factor denominators. Neither of those factor. They're just one term, so there's nothing I can do with those. So done. My LCD. Now notice these, oops, sorry about that. These are not super glued, right? There's no plus or minus signs holding them together. So I have a 5, an x, a 3, and an x. Well, 5 and 3, I can multiply both of those to turn them into a 15. And x and x, they both just have one x. So I don't need to change that. That part's already common, right? So I can leave just an x. I don't need to change that to an x squared just because it's already common. So multiply by what they're missing. So how do you multiply 5x to turn it into 15x? Well, you just multiply it by 3. So multiply the top by 3 gives me 21. 3x times what is 15x? Well, times 5. So multiply the top times 5. And that gives me, notice there's a plus sign in between. So 8 times 5 is 40. So that's step 3. Step 4, add your numerator. Well, that gives me 61 over 15x. Done. Restriction. X cannot equal, the only thing I'd get from there is it cannot be 0. Factor numerator, it is literally just the number 61. And then cancel, nothing goes into 61 and 15. I am done. All right, so hopefully you recognize why I don't need another x on the bottom, because I could make that a common denominator just by multiplying by a number, and it was able to make it the same. Okay, so as long as you can multiply by something and make them the same, that's what we're trying to do for the common denominator. All right, that is where we're going to stop today. We will get into some more difficult ones where you have to do a lot of factoring in the denominators, lots of pieces, and more parts to them. We'll get into that in the second video for this week. For now, let's see how we do with this. Practice the homework and kind of let me know if you have any questions, and then take the quizzes when you're ready. All right, make sure you're getting at least an 80% on those. Take them as many times as you can. Last week, a lot of you kind of stopped at 75, 76%, and then you didn't get credit for it. So make sure you keep trying, and you have one less this week. So just makes it a little easier this week. Material's a little harder, which is why we kind of scaled back a little bit. All right, let me know if you have questions. Otherwise, I will see you in the next video, guys.